1. Matter, from page 92 to 98 of Science Focus 9. What is matter? Matter is everything around you. It is any substance that both has a mass and takes up space. The states of matter are solid, liquid, and gas that we typically know about. And there's also plasma. Never heard of plasma? Plasma is the fourth state of matter. Plasma results when a large amount of energy is added to a gas. So found in lightning, neon signs, and the sun. So we can either have electrical energy that turns it from a gas to a plasma, or just a high temperature. Notice that the particles in a solid are very closely packed and very nicely arranged. A liquid, they're still packed in fairly close, but their arrangement is very less organized. And a gas, the particles are spreading out and moving quite far apart. So in a solid, particles are allowed to vibrate. They cannot move out of their position within that solid arrangement. So you will find this same atom here no matter what the whole time. It just has the ability to vibrate back and forth. In a liquid, particles also still vibrate, but they have rotational motion as well. This allows them to move kind of throughout. So this particle of the liquid won't remain in the same spot. We could find it over here after a bit of time. This is why in a liquid, if we added a drop of food coloring, we would see that over time, the molecules of the food coloring slowly dissipate and disperse throughout, okay? It's because they have both vibrational and rotational motion. In a gas, we have all kinds of motion. Gas particles travel in straight lines until they hit the sides of the container, and when they do that, they bounce and move. So a gas has vibrational motion. These can still be vibrating back and forth. They can still be rotating, so rotating around and around, which allows them to move. But mostly they have translational motion. Okay, so it can move all different directions. Translational movement, and they travel in straight lines. Plasma is when a gas has been heated really high. There's not too much about this motion that we need to know. It acts like its own thing. So what determines what state something is? The temperature. If we heat something from solid to liquid to gas and keep going to plasma, we have to increase the temperature the whole way. And it'll go through those four states. Pressure is also something we can look at. I'm going to kind of leave plasma out of this one. As I increase the pressure of something, compressing it, it can go backwards through the states. This isn't to say this is the only way we can change states is temperature and then pressure this way. I could decrease the temperature and move this way, or decrease the pressure and move this way. Again, pressure is just how much room something has. If it's a gas and has lots of room, I can compress it and it'll be under a higher pressure and it can turn into a liquid. If I continue to compress it, it will turn into a solid because they are just packing them so close. Again, kind of summarizing what we'd looked at, in a solid, the particles are packed so closely together that they only get to vibrate in place. In a liquid, the particles are touching but can flow past one another. It takes the shape of its container. In a gas, the particles are separated by very large spaces and move quickly in straight lines. They also take the shape of their container. A solid can hold its own shape. Changes in state. We can move from a gas to a liquid through condensation, or a liquid to a gas through evaporation. We can move from a liquid to a solid through freezing, or a solid to a liquid through melting. We can also go backwards here, okay? It looks like it's trying to say deposition here. Sorry, it's a little bit convoluted. I'll change that in my slides to make sure that it's very clear. That means we're going from a gas to a solid. Solid to a gas undergoes sublimation. Okay, so we can go directly from solid to gas. We just have to have really particular conditions. Typically, we see this transition from gas to liquid to solid, or solid to liquid to gas. But in like very specific conditions, we can have sublimation. The particle model of matter describes all particles. There's 5 points to it. All matter is made up of extremely tiny particles that we cannot see. Each pure substance has its own kind of particle that is different from the particles of other pure substances. So there's no anomalies, if you will, in that. Number 3, particles attract each other. So when they're moving, they do have attractions between one another. Particles are always moving. And particles at a higher temperature move faster on average than particles at a lower temperature. So as I heat something up, those particles are able to move faster and faster. As matter gains energy or heats up, the particles again move faster. When particles move faster, they spread out. This is how solids become liquids and liquids become gases. This is also why gases are less dense than solids and liquids. Density, remember, is mass per volume. So this has a low mass per large volume. Same number of particles in a smaller amount could be a liquid. And this, was the gas. We have the same mass in a much smaller volume. Therefore, this has a larger density. The classification of matter has this little flow chart. Matter can be deconstructed to either be a pure substance or a mixture. So all matter is either a pure substance or a mixture. Pure substances can either be an element, so just pure aluminum. It could also be a compound. So let's give that aluminum. It could also be a compound, like pure water. So H2O. In pure water, the only thing I have are water molecules. So it is a pure substance in that there's not two different types of molecules there. A mixture, we can have a heterogeneous or a homogeneous mixture. A heterogeneous mixture is one where there's multiple parts and we could see those parts typically. Or we've done something to keep those parts together. Okay. Homogeneous mixture is something like a solution. When you dissolve Kool-Aid, you create a homogeneous mixture. It is a solution. So heterogeneous mixtures have 3 different types. We have an ordinary mechanical mixture, a suspension, colloids, and then an emulsion is like a type of colloid. Okay, we're going to go through all of these. A lot of them were probably things that you recognize, but some might be new terms. So all matter can be divided into mixtures and pure substances. Again, pure substances are made up of only one type of particle, whether that is a molecule or an element. Mixtures are made up of different types of particles. The different particles can be separated somehow. So of the pure substances, an element and a compound were the 2 options there. An element cannot be broken down into any simpler substance. It is organized into the periodic table. So examples are sodium, aluminum, oxygen, nitrogen, elements from the periodic table. A compound is created when 2 or more elements combine chemically in fixed proportions. So fixed proportions just means, let's look at water as an example. For every water molecule, there will always be 2 hydrogens and 1 oxygen. So fixed proportions means I'm never going to find a water molecule that's H3O2. That's not possible. Okay, so fixed proportions means just as its chemical formula says. Carbon dioxide's another one. We can have compounds with 3 elements. So we could look at methanol. Has CH3OH. So we have carbon, hydrogen, and oxygen. It can have any number of combinations. What is key is that when we are looking at a compound, we are only looking at, for instance, water molecules, so pure water. We aren't looking at any mixture of 2 different kinds of compounds. That would be not a pure substance. Mixtures. That's what the combination of 2 compounds would be. So mixtures can be divided into homogeneous and heterogeneous mixtures. A homogeneous mixture could be a solution. It's uniform throughout, so you can't actually tell the 2 different compounds that are there. Examples could be chocolate milk, oxygen in the air, pop. When you look at it, you cannot see 2 different things. A heterogeneous mixture, there's 4 different types of those. Particles are not uniformly scattered. So we could either see all of the different pieces like in trail mix or cement, steak spice, salad. We could look at salad dressing itself when you shake oil in water, or even just like a creamy salad dressing could be considered a heterogeneous mixture. Again, there's 4 types. So the ordinary mechanical mixtures, suspensions, colloids, and emulsions, which is a type of colloid. An ordinary mechanical mixture is where you can see the different parts. They're big enough to see, and the particles will stay mixed. So relished, concrete, soil, you can see different pieces within this. A pizza, a chocolate chip cookie, my personal favorite. So you can actually see different parts of it, but it still stays stuck together or contained. A suspension is made of large particles that are uniformly mixed, but will settle if left undisturbed. These could be separated with a filter. These will scatter light, meaning it'll be reflected. So flour and water, charcoal and water, powdered chalk and water, like oil and water, we could mix it up and it'll settle, and we could separate those 2. Colloids are fine particles that are evenly distributed throughout a second substance, and it will scatter light. So hair gels, clouds, etc. And emulsions are a type of colloid in which there are liquids dispersed in liquids. They're an emulsifying agent, and it's added to mixtures to keep the particles from separating. They coat the different liquids to prevent them from clumping together. So mayonnaise, milk, jelly, salad dressing, the particles are actually coated with this emulsifying agent so that the particle itself will stay dissolved. Okay, so this emulsifying agent that's surrounding my blue particle allows it to stay dissolved in our solution. If this emulsifying agent wasn't there, the particle would settle out. Some practice, complete the learning guide for matter, and there's some additional practice in your textbook if you'd like to look at that.